Hi, hola, bonjour, and Salaam. Welcome to Blueprint Bazaar. In this fourth part of our plastic shredder machine full assembly walkthrough, we continue from where we left off in part 3. After optimizing the mate structure and refining the constraints between the frame and side plates, it's now time to bring in a crucial topside component, the hopper. This part is all about assembly. No modeling work is being done here. The hopper, already designed and saved from earlier stages, will be added to our assembly and precisely mated onto the shredder frame. This step might look simple at first glance, but it's essential for the machine's overall performance, functionality, and design flow. The hopper is the entry point for plastic waste, guiding it safely into the shredding chamber. If placed incorrectly, it can interfere with internal components or compromise feed consistency. We begin by opening our existing SolidWorks assembly from Part 3 and importing the hopper into the environment. Once inserted, we adjust its position manually to get a rough alignment above the frame structure. The hopper is designed to sit directly atop the shredder housing, aligning with the feed opening defined between the side plates. Using standard mates like coincident, distance, and concentric, we position it precisely to ensure both visual alignment and structural stability. As the hopper is mated into place, we take care to check symmetry, edge alignment, and orientation. It's important that the hopper sits evenly across the top, both for aesthetic balance and functional performance. Misalignments here could lead to material jamming, uneven flow, or even mechanical strain during real-world operation. By using well-defined mating references, such as planar faces and central axes, we make sure the hopper rests exactly where it's supposed to be. This part of the assembly also demonstrates good design intent. We want to be sure the hopper remains stable even if we later change the side plates or tweak the frame. That means applying mates that are reliable and flexible, not overly dependent on fragile references. This is a great moment for beginners and intermediate CAD users to understand how modular assemblies can be designed in a way that supports iterative improvements and easy part replacement. With the hopper now locked into position, we perform a quick clearance check to ensure there's enough space for the internal rotating components that will be added in the next phase: blades, shafts, and spacers. This visual check is brief but necessary, especially for designs where tolerances are tight or the geometry of the incoming parts hasn't been finalized. Our goal is to keep the upper structure light, well-aligned, and ready for dynamic movement underneath. This video may be short in runtime, but the value lies in understanding the importance of each assembly step. The hopper might be a single component, but its placement affects multiple downstream features, from the user's material input to how efficiently the blades perform. Taking time to mate it correctly ensures that future steps, like shaft installation and motion studies, go smoothly without the need to constantly revisit earlier parts of the design. That wraps up the assembly process for the hopper in Part 4. Thanks for sticking with us through this build process. If you found this helpful, please consider subscribing, liking, and sharing this video with others in the engineering, CAD, or DIY community. Stay tuned, and we'll see you in Part 5 as we move deeper into the shredder's internal functionality, where the real action begins. Until then, take care and keep building with purpose.